When two atoms have very similar attractions for electrons, then there's not a big enough difference that one can pull electrons more towards itself than towards the other atom. That results in them sharing, so it's a covalent bond. Co meaning share, valent, we are sharing only those valence electrons. When that happens and the sharing is totally equal, we call it nonpolar. So we'll see that polarity is a very important property or a very important fact in terms of explaining the properties, why certain molecules dissolve or have maybe a melting point or a boiling point or a surface tension that they have, which is different from another compound. So understanding something as nonpolar means that any electrons on average are shared perfectly. When an element like hydrogen is bonded to another hydrogen, the attraction between the two atoms is exactly the same. Their electronegativity difference is 0, and they share electrons perfectly equal. We consider things all the way up to 0.4 in terms of electronegativity difference to be nonpolar. So you could be given values, and we've got some values here. If the difference is 0.4 or less, we consider that to be mostly nonpolar. The most important one of this is carbon to hydrogen. Carbon to hydrogen is right on that line, but we generally classify it as nonpolar. The sharing of electrons isn't perfectly equal, but it's close enough that we don't have a big difference, or we don't really have a positive and negative part that has a significant difference on the properties. So sometimes you would be given exact electronegativity values, asked to subtract them, and determine if something is polar or nonpolar. You can be given the whole chart like this, or you could be given just a few specific values. Other times you are not given the entire chart or periodic table or all of the listings, and you're just supposed to kind of compare or make some generalizations. One thing, the further things are away on the periodic table, the more polar the bond becomes. So fluorine to chlorine, that's a difference of 1.0. That is greater than 0.4. We'll see that that's polar. But fluorine to bromine is an even bigger difference. So it's even more polar. So generally, two things that are right next to one another, there may be some polarity, but it is fairly small. And then as we go farther away, as you go 2 to 3 away, or if you go down and over, then that's when you're definitely going to see a bond that becomes polar. Another thing to note here in terms of patterns, the electronegativity difference, there's a fairly big jump going down columns, at least for the second, down columns from the second row to the third. Side to side is a little bit less, but we don't need to memorize exact values. Just know the closer they are, the less polar. The farther they are, the more polar. But do remember that hydrogen, for this sense, kind of belongs over here closer to its non-metal friend.